Hello class, I'm in a meeting right now for the new textbooks for next year. Today I need you to look at this video. It's on current electricity. I want you to fill out the review sheet as you go along. Pause the video as you see your answers. You can write them down. I would also have the PowerPoint up so I could go back and reference it. First thing, we're talking about current electricity, which is different than static electricity. In static electricity, the charges stay in one spot until they're moved. In current electricity, the electrons flow along a wire or some sort of conductor. We acted this out last week. If you remember, we had cards with negative signs on them. We were passing them around the room. Right now, this is the answer to number 1 on your review sheet. I would pause and I would write the answer. Once you've written the answer, I would like you to click here and look at the YouTube video that goes along with this slide. Moving on, we want to talk about the amp or ampere. An ampere would light up a large ordinary light bulb, one would. It's the unit for electric current. In other words, it's the unit that we use to describe how many electrons are flowing past a point in our conductor. I like this drawing. I think it does a nice job. Here's an ammeter. This little guy is a meter over here, right here, and he is counting how many electrons flow past him in a conductor in 1 second. We also acted this out last week. So, amp is a term for the amount of current flowing through the wire in a second. We want to talk about insulators and conductors also. Electric insulators are materials that do not let electricity move through them easily. This is why electrical cords have plastic or rubber coverings on them. That's to prevent you from being shocked because the electrons won't flow through it into you. An electric conductor, on the other hand, is something that lets electric current flow through it easily. Last week when we were playing with the static generator, you guys were the conductor and the electricity flowed through you. Insulators and conductors, if you go to this right here, this animation, it does a very nice job. I'd like you to pause the video right now, go there, and check out the animations that go with this. Resistance is something we've not really talked about, but we've just touched on it a little bit. Resistance is the opposition to how a conductor would let electrons flow. In other words, resistance is the conductor's ability to not let electrons flow. And because of that, friction will happen. It slows them down. They start to build up and they start to rub against each other. And when they do, the resistance causes heat. The unit for resistance is called an ohm. It's named after German physicist George Simon Ohm. In the picture down here, here's the voltmeter, and here's our flow of electrons along this wire right here. When it gets here, ohm, that's our resistance, is squeezing the wire, and he is preventing the electrons from flowing through. That's exactly what happens. It's kind of like in a hose. When you squeeze the end of the hose and the water doesn't come out anymore, and it backs up in the hose. So that's exactly what's happening, and that's what resistance is. It stops the flow of electrons, or at least slows it down. Now, I like this. This is a pretty good example. 2 factors that affect the resistance of water flowing in a pipe or its diameter and length. Well, the same thing also happens in a wire. If I have a very wide wire, there's lots of room. Think of it as a big wide hallway for all the electrons to flow down. I'm not going to have much resistance. If I have a very narrow hallway, I'm going to have a lot of resistance because the electrons are going to rub up against each other. Length also makes a difference. If I've got a short length, the electrons only have to travel a short distance. They're going to flow pretty easily. If I have a very long length, they have to go a greater distance. That's going to increase my resistance. Let me give you a good example. If I had extension cords plugged in from, let's say, Los Angeles, California to New York City, all the way across America, and at the end I plugged in a lamp, the lamp would probably not light up. Why? Because the extension cord would be so long that the electrons would not be able to flow through it and get to New York in order to light the lamp. Voltage is another subject we haven't touched on. The amount of work it takes for an electric current to move between 2 points is called electric potential difference. Here's what they're trying to say. If you know you have a positive side and a negative side on a battery, the more positives you have in that battery, the more easily it's going to pull negatives from the other side of the battery to it. So if you have a whole lot of positives, you're going to get a very good flow of negative electrons because they're going to be attracted to that positive. Now, the unit we measured the difference in these two is called a volt. Now, volt is like pressure, like something to push. It pushes the electrons along a conductor. If you increase the voltage, you increase the pressure on the electrons. So it's almost like with a garden hose. The more you turn on the faucet, the more pressure there is, the more water that's going to come out of the garden hose. At this time, I would like you to pause the video. I would like you to go here and watch this short YouTube video. Thank you. I hope the YouTube video was informative. If you look at this picture, this is a very good example. Here we got a pipe, and in the pipe we've got electrons flowing along it. It's actually a wire. But if you think of it as water, think of these as the electrons as little water molecules flowing through. How can you get more water molecules to flow through a pipe? Same way you get more electrons to flow through the pipe. You have to increase the pressure going through. Over here is our valve. If we twist our valve so less comes through, we've increased the resistance. In other words, we blocked off some of the pipes so that less water flows through. If we open it up all the way, we've increased the pressure, and then a lot of electrons can flow through. Now, all this can be stated in Ohm's law, which is voltage equals current times resistance. We use Ohm's law to find the voltage of a current in a circuit. We can also turn the equation around to the following. Current equals voltage divided by resistance. Is this something important to know? Yes, it is. Is it a question on your review? Yes, it is. Okay, at this point, I'm going to be stopping the video. I want you to watch it. I'm going to go over all this again tomorrow, so don't be panicked, but I would like you to fill out the review. Complete sentences. Thank you very much.